In this lesson, I want to show you how to use minimal APIs as an alternative approach to defining your API endpoints. Minimal APIs were added in .NET 6 as a more lightweight solution to create API endpoints, and they have since become very popular in ASP.NET Core. In most of my recent projects, I've been working with minimal APIs instead of controllers, so I think that it is important that you know how to use minimal APIs. I'm going to show you how to convert the bookings controller to use minimal APIs, but first let's discuss the reasoning for why minimal APIs were created. The first reason, in my opinion, is because of the complexity of implementing controllers. You have to use a base class to define your controller. You have to decorate the controller with a lot of attributes, which means you have to know which attributes to use. And then there is a separate discussion about the cohesion of your controller endpoints. What I mean by this is that although the methods inside of the controller, which represent your endpoints, they have almost nothing in common. The only similarity here is that we are using the iSender from Mediator to send the query or the command instance, but the actual logic inside is completely unrelated. The getBooking endpoint is responsible for getting a booking. The reserveBooking endpoint is responsible for reserving a booking, and there isn't a relationship between these two endpoints. This becomes even more prominent in large controllers containing dozens of endpoints and injecting many dependencies. In our case, our controllers are pretty thin because we are using Mediator. But with minimal APIs, you can generally improve your design because minimal APIs focus on a specific API endpoint. So let's slowly start to convert our bookings controller into minimal APIs. I'm going to start by creating a static method on the bookings controller, and let's make it a public static method returning the iEndpoint route builder instance. This is what we're going to use to create our minimal API endpoints. Let's give this method the name of map booking endpoints. This method is going to be an extension method on the iEndpoint route builder, and I'm just going to return a builder to start out. To be able to define extension methods in the first place, the class that we are using has to be a static class, which means I'm also going to get rid of the controller base inheritance. The instance constructor also doesn't make sense anymore, so let's remove it. And now let's see how we're going to fix our two endpoints. So let's first map the getBooking endpoint. This is going to be a get endpoint, so we call the map get method. We need to specify the fully qualified route because the route attribute that we specified here doesn't apply to minimal APIs. So let's grab the entire route, paste it here, and I'm also going to add the ID route parameter to match the getBooking endpoint. And then I need to provide a request delegate to satisfy my mapGet method. So I'm actually going to use the getBooking method itself. So let's pass it in, and I will have to make it a static method to be able to pass it as a request delegate. Now I can get rid of the HTTP get attribute because it's no longer required. The get method is handled by the mapGet call, and the route itself is already specified here. Notice that we also added our API version as part of the minimal API endpoint route. However, there are still a few things that you will need to configure to fully support API versioning, and I'm going to show you what they are in just a moment. But first, let's continue fixing the getBooking endpoint. What we are missing here is the iSender instance. So what we can do is inject this as an argument. So I'm first going to accept the ID from my route, and then I'm going to inject the iSender service. And minimal APIs will be able to resolve this, and I'm going to be able to call the senderSend method and send my query to get back a result. Now, the return type for minimal API endpoint is an iResult instance, and how you can get a result object is by calling the result status class, and then you'll see that the methods are pretty much the same as they were with a controller. So instead of saying OK, you're going to say results OK. Instead of saying not found, you will say results not found. And this wraps up the implementation of the getBooking endpoint. I mentioned that the route attribute doesn't make any sense, so I'm going to remove it. The API version attribute also won't work, as well as the API controller, and the authorize attribute, we can also get rid of that. So this is all that we're left with in the bookings controller. So let's actually rename this to be bookings endpoints. So I'm going to replace the controller wording with endpoints, and let me show you how to add authorization to your minimal API endpoint. You just have to chain a call to the require authorization method, which also lets you specify a policy. If you want to specify a permission as a policy, you can do that here. For example, let's say I have a bookings read permission. This is how I would pass it in. Alternatively, you can create your own extension methods to make this more intuitive, such as require permission or with permission, whatever works for you. And before I show you how to completely set up API versioning, let me also finish migrating the reserved booking endpoint into minimal APIs. So this is going to be a post endpoint. So I will say map post. The route will be the fully qualified route for the bookings resource. So this is going to match my route. And then I can use my reserved booking method and pass it in as a request delegate. I have to make it a static method. And let's get rid of the HTTP post attribute. A few more things we need to fix are the sender dependency. Let's inject that after our reserved booking request. So I'll define an iSender. Then we need to return an iResult from the reserved booking method. And let's call results bad request to return a response. And the results created at action doesn't exist, so you will have to use something else, and the result class contains the created and created at route methods. I'm going to use the created at route method, which matches the arguments that we are passing in here. So we can specify the route name, the route values, and the actual value that we want to return from this route. However, we need to make sure to decorate the original route, which is our GET request here, with this name. So I'll copy the name of get booking, and I'm going to call with name to give my endpoint the respective name. Let's also add authorization to our other endpoint, and then let me discuss what you're going to need to finish up your API versioning implementation. If you want to map a minimal API endpoint to a specific API version, you can call the hasAPIVersion method. And then I can pass in my API version instance, for example, version 1. However, this doesn't allow passing in a string value, so you'll have to specify it as a number. But an alternative approach, and the one that I suggest that you use, is passing in an API version set. Now, an API version set is available in the ASP versioning namespace. You can use the endpoint route builder to create a new API version set and define your default API version if you want to report the API versions or not. And you'll recall that this is similar to how we configure the API versioning options. And finally, you call the build method to get back an API version set. Then you can pass this to your with API version method and share it between your minimal API endpoints. This approach isn't really scalable, so let me show you a better way to do this. But first, let's map our minimal API endpoints. I'm going to map them right after the controllers, and I'm going to call the map booking endpoints extension method. So let's take the configuration for our API version set, and let's create the API version set here in the program file. I'm going to replace builder with app, and then what I'm going to do is map an endpoint group. So you do that by calling the map group endpoint, and this allows you to configure a prefix for all endpoints created inside of this group. Now what I want to configure is the API and the API version, and I can also pass in my API version set to this API group. Now this method returns a route group builder, and the route group builder also implements the iEndpoint route builder interface. So what I can do is call the map booking endpoints extension method on this route group builder, and this allows me to share my route prefix containing the API keyword and the API version and the API version set setup. Additionally, I can also add a call to require authorization to make all of my endpoints require authorization, but I also need to fix my booking endpoints configuration. Because this is now part of my route group, I can get rid of it here and only have bookings/ID and bookings. We can also get rid of the call to with API version set because it's taken care of by the route group, and this is what we are left with in the map booking endpoints method. The end result is not much different from the implementation that was using controllers, but it does have the benefit of using minimal APIs. And because minimal APIs are more lightweight than controller, they have a smaller memory footprint, which means less resource consumption, and they are slightly faster than controllers, which means that you can get more throughput or requests per second using minimal APIs. So if performance is important and you can't get the desired performance using controllers, you may want to consider converting them to minimal APIs. I also want to highlight that this implementation using minimal APIs will not be the final implementation of the Bookify API. I'm going to revert back to the implementation using controllers for the remaining examples, but you can grab the source code containing the minimal APIs implementation from the zip file under this video. This was a really fun chapter where we covered many different topics. You learned how to implement structured logging using Serilog and Seek. You also learned how to implement distributed caching with Redis. You learned how to add health checks and API versioning, as well as how to configure background jobs in the clean architecture. You also learned how to implement the outbox pattern to make publishing your domain events reliable and transactional. And lastly, I showed you how to use minimal APIs as an alternative to working with controllers for defining your API endpoints. In the next chapter, we're going to talk about testing in the clean architecture.